Throughout the years, scientists have made some discoveries that seem to hint at the existence of extraterrestrial life. But do they really? Let's find out. In 1976, NASA's Viking Mars landers detected chemical signatures that could be a sign of extraterrestrial life. During one of the experiments, Martian soil was mixed with special nutrients and then tested for the production of methane gas, and the test's result was positive. In other words, something in the soil was metabolizing these nutrients and producing the gas. Unfortunately, other experiments conducted on board the landers didn't show any evidence of life. It caused NASA to declare the result a false positive. And still, some scientists keep standing by the finding, arguing that the experiments on board were ill-equipped to look for a key indicator of life, organic molecules. In 1977, an Ohio State University radio telescope detected a bizarre pulse of radiation coming from someplace near the Sagittarius constellation. It lasted 37 seconds and was so unexpected that the astronomer who was monitoring the data at that moment scribbled, "Wow," on the telescope's printout. The thing is that the radio frequency of the signal is internationally banned on Earth. The signal could be the result of a supermassive astronomical event, or it could be sent by some kind of intelligent life with immensely powerful transmitters. So far, this mystery has remained unexplained. In 1996, NASA scientists announced that they had found something that could be microbes in a potato-shaped chunk of Martian rock. The meteorite might have been blasted off the surface of Mars in a collision. It had been wandering the solar system for about 15 million years before it fell in Antarctica. Analyses showed that the meteorite contained some organic molecules and tiny particles of the mineral called magnetite. It's sometimes found in bacteria living on our planet. NASA researchers used an electron microscope and announced that they had spotted nanobacteria. But since that time, this evidence has been called into question a few times. Some experts say that the particles of magnitude are not really similar to those found on our planet, and Earth's contaminants are likely to be the source of organic molecules. Jupiter's moon Europa has a bizarre red tinge. Some of the theories explaining this phenomenon have suggested the reason is frozen bits of bacteria, which are also responsible for the mysterious infrared signal the moon gives off. But this theory hasn't been proven yet. The existence of life in Venus's clouds might explain curious anomalies in the composition of the planet's atmosphere. Solar radiation and lightning are supposed to generate tons of carbon monoxide on Venus, but in reality, this gas is rare, as if something is removing it. Another weird thing is the presence of both hydrogen sulfide and sulfur dioxide in the atmosphere. Usually, these two readily react together. That's why it's rare to find them coexisting. The only explanation can be that some process keeps churning them out. But probably the most mysterious is the presence of carbonyl sulfide. The thing is, on Earth, it's only produced by microbes and not by some inorganic process. Some experts believe that microbes might be living in the atmosphere of Venus. The surface of the planet, scorching hot and acidic, isn't very suitable for the development of life, but up in the atmosphere it's moist and hospitable, with a pressure similar to Earth and pleasant temperatures. But again, we haven't received any solid proof yet. In 2003, scientists discussed the possibility that the traces of sulfur on Jupiter's moon Europa could be the waste products of colonies of underground bacteria. The compounds were first discovered by the Galileo space probe, which also found some evidence of a volcanically warmed ocean beneath the icy crust of the moon. The sulfur signatures look similar to the waste products of bacteria living in the surface ice covering lakes in Antarctica on Earth. But other scientists rejected the idea. They argued that the sulfur could have come from the neighboring moon. Io there, it's found in abundance.
From the tiniest ants to the mightiest galaxies, why do things work the way they do? If we imagine the universe as a giant puzzle, we already found some important pieces: electromagnetism, gravity, tiny particles, and so on. But even with all this, we can't get the full picture. We still can't figure out how everything works. What we're trying to find is the theory of everything. This is the mysterious theory that should be able to fit everything in our world together. For years, brilliant minds like Isaac Newton, Albert Einstein, Niels Bohr, and many others tried to derive this theory. But as you can imagine, it's not a simple task. Albert Einstein was one of the first to get very close to the answer. He spent his entire life watching and analyzing the world. As a result, he came up with his most famous equation, E equals mc squared. This equation tells us how energy and mass are connected. Energy can turn into matter and vice versa. But that's not enough, so he created his theories of relativity. One was called special gravity. It says nothing can go faster than light, and time can stretch or shrink depending on how fast you're moving. Then, he combined it with general relativity, which introduced gravity into the equation. He thought of gravity as the universe's way of bending space and time. Just like a fabric stretches when you place a heavy ball on it, space-time stretches when we place things like planets in it. This effect is what we call gravity. Einstein also wanted to connect gravity with the other forces, like electricity and magnetism. That way, everything could be together in harmony. And there were scientists who decided to help him with that. Their names were Theodore Kaluza and Oscar Klein. In the 1920s, they decided that it would be cool to add extra dimensions to our universe. Electromagnetism explained how electricity and magnetism work together. And now, Einstein, Kaluza, and Klein wanted to add relativity to it, like mixing several flavors of ice cream to create a super delicious universe sundae. To make this wild idea work, Kaluza and Klein had to add a whole new dimension to our world. We usually think of our world as having 3 dimensions, like length, width, and height, plus time. But these scientists created the 5th dimension, although it's all tiny and hidden, so you couldn't spot it in your everyday life. All this gave us a more or less full picture of the world. Many even thought that Einstein did it, found the theory of everything. But if only things were that simple. Unfortunately, even though Einstein was a genius, he couldn't unite everything. You know what screwed things up for him? Quantum mechanics. Quantum world turned out to be insane. When we looked at the particles, we learned that they could do magical tricks. For example, they could be in 2 places at once, or disappear and reappear again out of nowhere. Einstein couldn't explain that. He wanted things to be logical and predictable, like knowing exactly where a particle is and how fast it's going. But quantum mechanics showed that our world is much more complicated, weird, and random than what we thought. But even though Einstein didn't explain absolutely everything, his legacy still lives on. Today's scientists are picking up where he left off. So how close have we gotten to the theory of everything since then? Well, quantum mechanics tried to nominate its candidate, string theory. This hero emerged in the 1980s. Quantum physics pals had a wild idea. What if the tiniest bits of everything in our world weren't particles, but super tiny strings? Yeah, like guitar strings. Almost. They look like little dots to us, which is why we see them as tiny particles. But if we looked at them under the best microscope ever, they would look like little loops. In that case, everything in the universe is made up of these little vibrating strings. Just like different notes on a guitar string make different sounds, these tiny strings can vibrate in different ways. And each way they vibrate creates a different particle. One note might give us a particle we call an electron. Another vibration could be a particle like a photon, and so on. But there is another cool idea that string theory suggests. It suggests that our universe has more than just the usual 3 dimensions we can see, like up, down, left, right, and forward and backwards. What if there are extra hidden dimensions that these strings can wiggle in? And theorists say that they might be up to 10 or even 11 of these dimensions. At first, everyone thought that this was it. This could be the theory of everything. But just like in the movies, when everyone thinks that they've defeated the villain, more problems pop up. String theory didn't fit the universe's rules discovered by Einstein. This is the last piece of the puzzle they've been trying to find for many years. If string theory supporters figure out how to connect their ideas with Einstein's theories of relativity, they'll finally be able to explain all the things ever. And they made some attempts. String theory began to divide into many branches. For example, it gave rise to the multiverse theory. Alright, we know that all the tiny strings can vibrate and wrap in different ways. There are many ways for each string to vibrate. The combination of their vibrations give many possible results. And there are trillions upon trillions of these strings. And just like one musical note can help to create different harmonics and songs, strings can create different versions of the universe. Each version might represent a universe with its own set of physical laws and properties. You probably heard about the parallel worlds. Well, it's a real scientific concept. The multiverse theory says that our world isn't the only one. There's an infinite number of universes and their number is constantly growing. Let's say you're baking cookies. In one universe, you make chocolate chip cookies. In another universe, you make oatmeal raisin cookies. And yet, in another universe, you make them with peanut butter. Even for such a small decision, there are a lot of parallel worlds. Something like this is very hard to even imagine. And these are only those universes that are similar to ours, where identical copies of us live. Some universes might be completely different. They might have different constants of nature, like the strength of gravity or the speed of light. They might have things that we can't even think about. Of course, this is just another theory. There's still a big debate about it in the world. It's a fascinating idea, but there's no way for us to test it with our current technologies. These universes, even if they exist, are way beyond our reach. One of them is called M theory. It was proposed in the 90s by an awesome scientist, Edward Witten. M theory is like a super advanced version of string theory. Just like in regular string theory, it suggests that everything in the universe is made up of tiny vibrating strings. But M theory says that these strings aren't the only things out there. There are also things called branes, short for membranes. Imagine these branes like sheets or surfaces that exist in higher dimensions. We can't see them, but they can interact with the strings in interesting ways. M theory was basically juggling other theories, trying to solve the problem in everything. It tried to unite every version of string theory into one big idea, and also combine all this with Einstein's ideas somehow. It also high-fived Stephen Hawking's ideas about black holes along the way. But even with M theory, we're not at the finish line. No matter how hard we try, we still can't explain absolutely everything. The biggest problem is trying to unite relativity with quantum mechanics. So far, no one could do this. These were our attempts to come up with a theory of everything so far. Will we be able to derive it one day? Who knows? There are many tricky pieces still missing, but we keep learning and creating new tools to explore our world. And maybe one day, we'll finally find out the answer.
Are we really by ourselves in the universe? It's a daunting question that's been haunting us for centuries. No wonder scientists have tried to come up with all sorts of ideas as to why. One of the strangest theories concerning our lack of contact with other life forms is named the dark forest theory. Let's start small, well, sort of. We'll focus on our Milky Way for now to better understand this theory. Our cosmic neighborhood is a galactic wonderland, sprinkled with 200 billion twinkling stars and maybe around 100 billion planets. So let's get hypothetical for a moment and say a tiny part of those habitats hosts life. Further, out of those life-bearing planets, a few might have evolved into intelligent beings. Given that, you'd think we'd be knee-deep in weird-looking neighbors, some of whom might be actively trying to find us or might just be out there, waiting to be discovered. Now, let's put a little science into this science fiction scenario. We have something called the Drake equation, which is a kind of universal roll call that estimates how many smart civilizations could pop up in our galaxy. You can think of this equation as the super smart roadmap. By playing around with a few important factors, the equation hints that there should be around 20 civilizations just in our galactic backyard. So why haven't we stumbled upon any yet? This theory isn't an easy task. It's a mixed bag of multiple variables, like the average number of planets per solar system that could potentially host life, or the rate at which stars suitable for intelligent life are formed. A tricky part here is that astronomers have yet to solidify the exact values of these variables, which means our calculations are just approximations for now. But back to the Milky Way, shall we? Feed in our hypothetical assumptions, crunch the numbers, and you get at least 20 civilizations. Yet somehow, our cosmic switchboard remains weirdly silent. How come? This radio silence has its own name, too, the Fermi paradox, named after the guy who first thought, "Hey, where is everybody?" over 50 years ago. Since then, we've had a lot of different theories trying to solve this mystery, all tinkering with different aspects of the Drake equation. Some folks think the appearance of life is a rare event. Others think that getting from bacteria to advanced beings is the tricky part. Yet, some reckon that civilizations might either wipe themselves out after a short lifespan or never even get to invent something they could communicate with. But there's one theory that tops all others in its creepiness: the dark forest theory. According to it, the universe is a huge cosmic version of a haunted forest. And other types of creatures are out there, playing a game of hide and seek. They're intentionally keeping silent. Why? Well, the dark forest theory was best explained in a sci-fi novel, and the rationale goes something like this. For starters, every life form wants to stay alive. I'll buy that. If we go with that assumption, it's impossible to be sure whether other life forms might harm you if they get the chance. So, the safest bet is to take them out before they find the right time to do the same to you. Frankly speaking, it's the universe's version of the survival of the fittest. In this scenario, making contact with others becomes the most dangerous game, as it could lead to your location being traced and you being wiped out. How human. This results in everyone keeping quiet, a kind of universal shush, where every civilization tries to hide in utter cosmic silence. But hey, is this just an idea good for a thrilling novel, or does it have some real-world implications? Well, the theory was suggested by scientist David Brin as a possible explanation for the lack of radio evidence for non-Earth-like life. He went as far as imagining it would be robots that would do the dirty work of wiping out civilizations. But how realistic is this theory anyway? Well, it doesn't require us to assume a lot of stuff about the behavior of all foreign civilizations. Just one advanced race behaving this way could explain our observed reality. And it might explain why we've not picked up any advanced radio chatter despite a century of eavesdropping. It's possible that other creatures like us are too terrified of being noticed and have gone radio silent on purpose. But, and it's a big but, like mine, it does base itself on the notion that other species share our level of risk aversion and logic, or that there's a rogue civilization out there picking off anyone they perceive as a threat. And that's a pretty significant assumption. If that doesn't sound creepy, this next piece of information certainly will. For about a century now, we've been shouting our existence into the cosmos. If this theory proves to be correct, every other civilization within 100 light-years of us might be getting our signals and knowing exactly where we are. And if we have reasons to hide from them, as suggested by some like Stephen Hawking, we might already be in trouble. But what if this theory isn't true? What if, sooner than we'd like to imagine, weird galactic creatures will indeed try to reach us? The truth is, most of us wouldn't even know what to do. Hey, let's not get over ourselves. In fact, some scientists are tackling this issue head-on. For the first time since the 1980s, specialists are trying to cook up a how-to guide for when we inevitably bump into cosmic neighbors. For instance, some researchers believe we've got to do more than just worry about how these life forms could shake up our world. If they send any type of radio signals down here, we've got to think about our reply. What are we going to say? Hey, we're humans. Nice to meet you. Absolutely not. We've got to do better than that. See, the only plan we've had till now came from a rough blueprint dating from 1989. This guide is a bit wishy-washy on what to do when the entire world gets the outer worldly text. Mostly it says, hey, let's share the news with everyone. But then what? If we confirm it's legit, officials will need to ask the United Nations for advice. But hey, does the United Nations even have a plan? Maybe, who knows? We've been doing loads of space exploring lately. Some say we've stumbled upon water on Mars. Others are sure we've spotted some planets that could be twins to Earth. So, the idea of finding life elsewhere isn't that far-fetched. But even after 100 years of trying to chat with cosmic beings, it's still a one-sided conversation. This new protocol isn't just about chatting up outsiders. It's also going to act as our cosmic voicemail, checking messages from outer space. It aims not just to decode the external lingo. It's also planning to figure out what these messages could mean for us. The plan is also to draft reports about how different policies could impact us and set up guidelines on how to respond to these space texts. So, will we ever get a message from our cosmic mates? Only time will tell. But what we do know is that we just can't wing it. We can't be caught off guard and start a planet-wide frenzy when we get that otherworldly WhatsApp. We gotta have a plan, and we gotta have it ready for when we're face-to-face with the real deal. I mean, we've come across a lot of potential such sightings, but none of them proved to be genuine. On that note, U.S. authorities checked over 100 cases of weird stuff going on in the skies. I'll spare you the details, but not one green creature was ever found. More like drones and similar stuff floating around. So, as we stand on the cusp of this potentially game-changing event, we must strive to be prepared. Whether our intergalactic neighbors drop us a text tomorrow or centuries from now, we need a plan. After all, this could change everything we know about our universe and our place within it.
The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the moon's poles, however, the temperature is always at around minus 400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon, and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color, depending on various phenomena. The moon, seen near the horizon, will most likely be yellow or red tinted. The rarer blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days.
For centuries, people believed that all swans were white because that was all they had ever seen. They thought it was a universal truth. Then one day, someone discovered a black swan. It was a surprising and unexpected event because it went against what everyone believed. So yeah, the theory is named after this idea of a rare and unpredictable event that goes against our assumptions and expectations. It isn't related to the Darren Aronofsky movie. You know, the one starring Natalie Portman as a committed dancer? Nassim Nicholas Taleb is the person who named this theory. He suggested that these types of super rare and unexpected events are impossible to predict, but they can have a massive impact on individuals, businesses, and societies. The theory was originally used to explain financial markets, but has found its way into various fields. Taleb calls those extremely rare events black swans. Now, these events are so rare that the usual tools of probability and prediction, like the normal distribution, don't really work. They rely on large populations and past data, which we don't have for rare events. So, trying to use statistics based on the past won't help us predict black swans. Let's dive into some examples of past black swan events. The rise of the internet is actually a great example. It's now hard to imagine a time when people couldn't Google their burning questions or watch funny cat videos online. The internet's growth and impact caught many by surprise. It transformed the way we communicate, access information, and even buy fluffy socks without leaving the couch. A digital revolution nobody truly saw coming. Recently, we found an infant black swan on the internet: the emergence of cryptocurrencies. Bitcoin and other cryptocurrencies created new forms of decentralized digital currency and disrupted traditional financial systems. Then we have the invention of smartphones. Picture a world where phones were chunky, had buttons, and only made calls. Suddenly, boom! Smartphones turned everyone into walking wizards with tiny devices in their pockets. From taking selfies to driving with GPS, these pocket-sized marvels changed the game, surprising us all with their incredible capabilities. Here we can also mention the rise of social media. The emergence of platforms like Instagram revolutionized communication, enabling people to connect and share information globally. The creation of the internal combustion engine was a game changer too. Long ago, horses trotted along the streets, leaving a different kind of horsepower behind. But then, ta-da! The internal combustion engine roared to life, propelling cars and transforming transportation forever. Who would have thought that a mechanical contraption could replace our equine friends and pave the way for road trips and drive-thrus? What about black swans related to our bodies, like decoding DNA? Once upon a time, DNA was a mysterious code, like a secret language of life itself. Then, science unraveled its secrets, revealing the blueprint that makes us who we are. This groundbreaking discovery in genetics opened doors to medical advancements and personalized medicine. Imagine you're a scientist working in a lab. One day, you forget to clean up your petri dishes. You know, those plastic or glass things commonly used for growing microorganisms. Then, you leave for a vacation. When you return, you find a happy accident. A mold called penicillin has grown on one of the dishes and exterminated the bacteria around it. That's what happened to Alexander Fleming. This accidental encounter with mold led to the discovery of penicillin. Hello, one of the most important medications in history. At the time, bacterial infections were a major threat to human health. Fleming's chance observation opened the door to a whole new way of fighting infections and revolutionized medicine. Now let's take a peek at Europe in the 14th to 17th centuries. It was like a scene from a historical movie. People are emerging from the Dark Ages, embracing newfound knowledge and experiencing an explosion of creativity. This period is none other than the Renaissance. It's a black swan too, because during that time, there was a tremendous surge in artistic, scientific, and philosophical achievements. Incredible minds like Leonardo da Vinci, Michelangelo, and Galileo were pushing the boundaries of human knowledge. The Renaissance was like a giant wake-up call for Europe, shaking off the cobwebs of the past and embracing a new way of thinking. It was a black swan event because it changed the course of history and ushered in a period of immense progress and innovation. It reminds us that sometimes, out of the blue, a wave of inspiration and brilliance can transform the world. Let's take a step back, or 1,000 steps further, and consider the moon landing. The Apollo 11 moon landing in 1969 was an extraordinary feat of human achievement and a positive black swan event. It showed humanity's potential for exploration and scientific advancement, inspiring generations and pushing the boundaries of what was deemed possible. Not all black swans are good and positive, though. When it comes to the stock market, a black swan event is like a super rare market crash that goes way beyond what anyone could expect. We're talking about events that statistically should hardly ever happen. The Great Depression is a classic example of a black swan event. It happened in 1929, but its effects lasted for a long time. The economy was booming with happy days. Then, the stock market crashed and everything went haywire. It was almost impossible to predict, like trying to guess the lottery numbers but on a global scale. The world had never seen such a massive economic meltdown. At its peak, 25% of Americans found themselves without a job. The economy took a nosedive. The US GDP dropped by 30%. Over 9,000 banks waved the white flag and said, "We're out." Oh, and there's something called a gray swan event, too. It's not as rare as a black swan, but it's still an outlier. The good news is that gray swans are a bit more predictable than black swans, so we can better prepare for them and take some measures to protect ourselves. Let's play a little thought game. Imagine we're weighing a bunch of people, and one of them happens to be the heaviest person in the world. Even if that person weighs 2,000 pounds, it doesn't really make a big difference in the overall average weight of everyone we weigh. It's like a drop in the bucket. This shows that extreme outliers like this super heavy person don't have a huge impact on the average. Now let's do a similar experiment, but this time with wealth. We gather a group of people, including one billionaire. What if that billionaire's wealth is 99% of the total group's wealth? Unlike the weight example here, the outlier dominates everything else. This is what Taleb calls extremistan, where a small number of people have a huge portion of wealth, while others have very little. Taleb argues that the modern world operates more like money. It's mostly digital and not constrained by physical or biological limits. While most people don't make a lot of money, a few can make a ton. The same applies to other areas like music, book sales, and more. This winner-take-all system rewards a small number of individuals disproportionately. We tend to believe we understand why these outliers exist. We think it's all about thinking outside the box. starting a revolutionary company and working tirelessly. But what about those people who did all these things and failed? You don't often hear about them or find shelves full of books about their failures. There's a bias in the stories we hear and the information available to us. In the end, we became more vulnerable to black swans. So, whether it's a mold leading to life-saving antibiotics or an economic crisis, these events of the black swan theory show us that unexpected events can have impacts on our lives. By the way, the odds of being born are 1 in 400 trillion. For all we know and don't know, being born is an unimaginably improbable event that nobody could have truly foreseen. So if you're alive, in a sense, you're a black swan too.
The universe is expanding, and if it's expanding, then it probably had a beginning somewhere. Now, all we have to do is to run time backward and see where the beginning was. It took the scientists many more years to come up with a full-fledged theory, the Big Bang Theory. And here it is. Nothing has ever been anywhere, because neither when nor where existed. But actually, no. There was one thing. It was the so-called cosmic singularity, a state of our universe in which it was incredibly small, dense, and very, very hot. Imagine if our universe was compressed into a small ball. The pressure and temperature inside would be enormous. At some point, it became impossible to withstand them. And here comes the Big Bang. It was an outburst of energy and matter that created everything we see now. Time and space, basic physical forces. It also scattered quarks everywhere. These quarks, tiny particles that make up our world, were all boiling in an incredibly hot cosmic broth. When it cooled down, gravity began to attract them to each other. They gathered into atoms, then molecules, and then into the first objects in the world, stars. But what was before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, has devoted his whole life to solving this mystery. After learning about the Big Bang Theory, Guth found some flaws in it. For example, the distribution of matter was very even, although it shouldn't have been. If we drop the balloon filled with paint down, it will burst. We'll see absolute chaos on the canvas. But the early universe don't look like. The early universe was very even and proportional. That was Guth's discovery, the theory of inflation. Here's what it says. Even before the Big Bang, there was some kind of force that could give the bang a strong acceleration, something that was able to distribute everything in space instantly and evenly. Martin Boyovald is a German professor of physics, and in his opinion, the universe was born quite differently. According to Martin's theory, the singularity couldn't just appear out of nowhere. Let's look at a pendulum on the old clock. The pendulum rotates back and forth. Its movement is smooth, continuous, and non-stop. This is how we usually see time. It flows and never stops. But quantum time doesn't work that way. It consists of small segments and makes short pauses. And just like with the second hand of a clock, the beginning of one segment of time is always the end of another. According to the Big Bang Theory, once upon a time, our universe began to expand, inflate like a balloon. But sooner or later, it will blow away back. The universe will start shrinking and return to the state of cosmic singularity. And then, the Big Bang too. Nothing appears out of nowhere and disappears into nowhere. According to Boyovald's theory, the beginning of each universe is the end of the previous one. Our universe is not at all the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. So for now, all this is just a hypothesis. But some people come up with even stranger ideas. Neil Turok, a South African physicist, and his colleague Paul Steinhardt, an American theoretical physicist. They say that yes, our universe isn't the first one. Our universe is just one of an infinite number of others. And all of us are stuck in a cycle of endless rebirths of parallel worlds. According to this theory, our universe is located inside a so-called brain, as in membrane. In other words, we're stuck in some kind of elastic surface that's capable of contracting, stretching, oscillating, and so on, like pieces of fabric on a rope. Another universe may be an inch from ours, but we can't see it. That's because there's a tiny space between us, and this tiny space contains the fourth dimension. How do these universes originate? Through brain collision. These brains are getting closer to each other very, very slowly, until they finally collide. Their collision creates two big bangs and two parallel universes. Then they're moving away from each other. The created worlds continue to live. We're currently at this stage. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we did collide with another universe, that would explain everything. Which idea is closer to you? How about the idea of subscribing? Subscribe.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the Moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the Moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the Moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the Moon, too? Now, think about the vastness of the universe. Our galaxy contains between 100 and 400 billion stars. Many of them can potentially host planets. Many of those planets might have water in them and be capable of supporting life. And this is just the Milky Way alone. What's the likelihood of other intelligent civilizations existing out there? Well, there's a famous formula called the Drake equation. It's a mathematical tool to guess how many civilizations from outer space might be able to talk to us in our Milky Way galaxy. It was made by a scientist named Frank Drake in 1961. Here are the variables in it. N is the number of civilizations we could potentially talk to in our galaxy. R star is how fast new stars are born in our galaxy. F sub p is the fraction of stars with planets around them. N sub e is the average number of planets around each star that could support life. F sub L is the fraction of those planets where life might actually start. F sub I is the fraction of planets with life that could become smart civilizations. F sub c is the fraction of smart civilizations that send signals into space. And L is how long those civilizations keep sending signals. Of course, we won't get an exact number like this. It's more like an educated guess, and we don't have any answer to that. But based on at least some information we know, there might be around 100 million worlds where life should have evolved. But if that's the case, then why haven't we met or heard from anyone? This is called the Fermi paradox. It's named after the famous physicist Enrico Fermi. He asked a simple but very important question: where is everybody? Our universe should be filled with chatty extraterrestrial beings, advanced civilizations, and spaceships zipping around. Yet, when we look up at the night sky or listen with our radio telescopes and antennas, it's eerily quiet. All we get is the so-called Great Silence of the universe. Scientists from Oxford University's Future of Humanity Institute are trying to answer this question. And they're not the only ones. A group called METI, for Messaging Extraterrestrial Intelligence, organized a workshop in Paris in 2019 to explore this mystery. The workshop brought together experts from various fields, like astrophysics, biology, psychology, and so on. One of the ideas discussed is called the zoo hypothesis. It suggests that perhaps other civilizations do exist, but they're simply not broadcasting their presence. Maybe they know that making direct contact with us could be risky for both sides. So they're intentionally avoiding us, because they're watching us like observing a zoo. They could be using advanced technology we can't detect. There are also some optimistic explanations, like time delays. Space, as you know, is unimaginably big. The time it takes for signals or information to travel across the universe is enormous. It's possible that other civilizations exist, but their signals haven't reached us yet, or ours haven't reached them. But some explanations aren't very optimistic. Like, some scientists think Earth might really be unique. Maybe the conditions that led to life and intelligent beings are so incredibly rare that there are no other planets like ours. Scientists point out that there are many planets similar to Earth, and some are much older. This means there should be plenty of planets where life could evolve. Recent research also suggests that life might be way more resilient than we thought. And, well, while it increases the amount of life existing out there, it also increases the chances that intelligent life doesn't last very long. It might destroy itself before it can spread to other parts of the universe. This is a concerning idea for the future of humanity. The researchers also considered that many planets might be at a similar stage in their development. That's why it's hard for them to explore the universe at the same time. But even they agreed that this explanation is way too far-fetched. And finally, one of the big potential explanations is called the Great Filter. This idea was suggested in the 1990s by Robin Hanson. It says that for life to develop and become advanced like us, it has to overcome some really tough challenges. First of all, the planet itself should have a good stable star and good enough conditions on it. Then life has to start on that planet. These life forms need to be able to reproduce using things like DNA. Simple cells must evolve into more complex cells. More complex organisms with multiple cells must develop. And eventually, these organisms must figure out how to reproduce, which increases genetic diversity. And finally, these organisms must be smart enough to use tools, create, and explore things. Finally, they should colonize other planets and star systems without destroying themselves. And maybe one of these stages is so incredibly hard that most civilizations don't make it past that point. This challenge could be something like developing intelligence in the first place, or it might be the struggle to avoid self-destruction. So perhaps life isn't rare at all, but most of it doesn't go beyond simple tiny organisms like bacteria. Even if the universe is full of bacteria, they don't become advanced enough to build spaceships. The Great Filter might also be something from outside, like a huge asteroid crashing into a planet, a dangerous burst of gamma rays, or a massive star going supernova. These events could destroy life on any planet, no matter how advanced they are. So, if we've already passed this challenge, it means we could be the only ones in the universe and we can explore it. But if we suddenly hear from a super advanced civilization, it could mean the hard part of the challenge is still ahead of us. Now, the Fermi paradox focuses on intelligent civilizations. It just implies that there should be civilizations more advanced than us, or at least as intelligent as us. But if you think about it, why should extraterrestrial life be similar to ours at all? It might be completely different for many important reasons. Life elsewhere might have developed under completely unique conditions. This could lead to forms of intelligence and consciousness very unlike our own. For example, it could have evolved into highly advanced forms that aren't based on biology as we know it. These beings could exist as energy-based entities, silicon-based life forms, or even as a hive mind. And because they have evolved completely differently, they may be capable of things that we aren't capable of. For example, we can't see the entire light spectrum. Our eyes also can't perceive cool things like dark matter. But who knows what the vision of extraterrestrial beings may be capable of? Their abilities might even extend beyond our three-dimensional perception. They might be able to perceive and interact with higher dimensions, which is why they could have unique, interesting insights into the nature of our world. Or maybe they've learned to think outside of time, like in the movie Arrival. For us, we still haven't met them, but for extraterrestrial beings themselves, the concept of time doesn't exist at all. They're simultaneously in the past, present, and future. For humans, something like this is hard to even imagine. Plus, even on Earth, we don't fully grasp how consciousness works or why it exists. We're not even sure when exactly we became conscious. So even if we do encounter extraterrestrial life, it will be hard for us to understand them or communicate with them. We think that they might have entirely different language systems, symbols, and so on, but they might not even have any communication systems at all. As you can see, the possibilities are endless. Evolution is a process that can go in many different directions. It's possible that extraterrestrial life developed in ways we can't easily understand or even imagine. These things are intriguing to think about. There are still no easy answers. The Fermi paradox remains one of the most exciting and mystery questions in science. Scientists continue to explore these mysteries through a multidisciplinary approach. They're hoping to find clues that could lead to breakthroughs in our understanding of alien intelligence. And until we find a definitive answer, we can keep sparking our curiosity and imagination.
AI can drive a car, design trendy clothes, give you emotional support, and it looks like it can also help us find answers to centuries-long mysteries. Researchers from Yamagata University Institute of Nazca and IBM Japan used a deep learning AI model to find new Nazca lines. Those are distinct white lines on a rusty red background that you can see from a plane while flying over the deserts of southern Peru. Scientists have tried to decipher the meaning of the Nazca lines ever since they were first discovered in the 1920s. There are straight lines, rectangles, triangles, and swirls. There are also some giant drawings. You can see a monkey, a whale, a condor, a hummingbird. The 4 recently discovered geoglyphs, which is the scientific word for those drawings, show a humanoid-like figure holding a club, a fish, a bird, and a pair of legs. What is the hidden symbolism of all that? And why did the Nazca people decide to draw a humanoid in the desert? And did they even know who humanoids were? Let's dig into history to find some answers. The representatives of the ancient Nazca culture created their famous lines more than 2,000 years ago. The geoglyphs have stood the test of time thanks to a dry climate and strong winds in the desert. Scientists found that to form the lines, the Nazca people scraped off the top layer of pebbles, revealing the contrasting soil beneath. The soil's color varies from reddish-brown to yellowish-gray. It makes it look like the lines are constantly changing appearance. It looks like the creators first made small-scale models and then enlarged them to create the full-scale designs we see today. In total, there are more than 800 straight lines, around 300 geometric figures, and 70 animals and plant designs. You can find the first mention of the lines in the 16th century Chronicle of Peru, where they were first described as trail markers in the desert. Since you can't really study the lines and their symbolism from the ground, those geoglyphs only became world famous only in the 1930s. It was the start of the era of commercial planes, so more and more people could witness the lines from their window seats and spread the word. During his research a decade later, Professor Paul Kosuk noticed that one of the lines aligned with the setting sun on the day after the winter solstice, which is the shortest day of the year. He supposed that the lines had some astronomical significance. German researcher Maria Reiche, who got the nickname the Lady of the Lines, supported the theory that the geoglyphs served as a calendar and some sort of astronomical purposes. She spent 40 years studying the lines and literally swept them inch by inch. She also moved into a small house close to the lines to protect them from unwanted visitors. And that's how the Nazca Lines mystery was solved. Just kidding. In the 1970s, American researchers began to question astronomical theory. In a region like Nazca, one of the driest places on Earth with only around 20 minutes of rain per year, water is a real treasure. So the straight lines and trapezoids could have something to do with it. They could have been an ancient version of Google Maps, pointing at locations for rituals that the local people organized to get some water and help their crops grow. The images of animals in the Andes region are also related to water. Spiders are thought to be a sign of rain. Hummingbirds symbolize fertility, and monkeys living in the Amazon mean an abundance of water. That could explain the choice of symbols in the desert, but there's no strong proof to support this theory. So the work on explaining the meaning of those mysterious geoglyphs is going on. In the 21st century, the Nazca Lines have become the research ground for archaeologists from Yamagata University. Masato Sakai, a professor of archaeology, together with others on the team, are using high-resolution aerial photography and drones to discover and catalog the lines. They found images of humans, camelids, birds, orca whales, cats, and snakes, most likely created between 100 before current era and 300 current era. Some of the images are around 10 to 20 feet long, and that's why they were pretty tricky to notice. The largest geoglyphs are 1,200 feet across, which is about the height of the Empire State Building. The researchers believe the Nazca Lines were a form of communication in the desert for their creators. The linear ones pointed the direction from valley to valley. The ones drawn on slopes seem to have been drawn along ancient pathways between settlements. Professor Sakai explains that discovering new lines is tricky. Some of them are so poorly preserved that it's hard to spot them in aerial photos. There are also irrigation systems and roads all across the Nazca region, and it complicates the task. And that's where AI comes in handy. The team showed it pictures of previously explored Nazca Lines so it could learn what to look for. Then, AI went through tons of footage taken from planes and satellites and also laser data from previous surveys to identify the lines scientists hadn't found before. The system works 21 times faster than humans, and it made some curious discoveries. Scientists then traveled to the locations it chose to verify the findings. In 2019, AI helped to discover a humanoid-shaped character with a rectangular head who is holding a stick and wearing a headdress. It became a real puzzle for the scientists trying to understand the creature's role in ancient society. The little guy is neighbors with another famous geoglyph. It's a hermit, which is a subgroup of hummingbirds that lives in the forested regions of northern and eastern Peru. The largest of the recently found geoglyphs is a pair of legs. It's more than 250 feet across, about 4/5 as tall as Big Ben. Could be an homage to some ancient supermodel. The fish and the bird are around 4 times smaller. Why they are where they are is still a mystery. Listing new geoglyphs isn't the only way AI is helping scientists. It's doing a lot of good for astronomy. It analyzes vast amounts of astronomical data and uses its algorithms to identify patterns, classify celestial objects, and even predict new events. For example, AI models have been developed to detect and categorize galaxies, search for exoplanets, and identify rare cosmic phenomena. It also helped analyze data obtained by the Kepler mission to discover new Earth-sized planets circling other stars. AI is also transforming the field of chemistry. Machine learning algorithms can predict chemical reactions, discover new compounds, and optimize chemical processes. All of this helps scientists save a lot of time and resources in the labs. If you've ever written a thesis, you know that analyzing vast chunks of information can take forever. Now imagine you need to analyze the archives of the British Library's national newspaper. It's piles and piles of history. So, researchers are teaming up with the curators to develop special software that can analyze the vast amounts of data extracted from these collections. Computational linguists and historians will be able to delve deep into the past and get some insights into changes in society and culture. They'll focus on key periods and track how advancements in technology shaped various aspects of society. AI even helps in the conservation of seals. It's really expensive and challenging to monitor certain species of those cutie pies living in the sea ice zone. Using high-resolution satellites, researchers can now identify the seals in photos, which already helps. But manually counting seals across huge areas of ice is like putting together a jigsaw puzzle of a blue sky consisting of 1,000,000 pieces. It takes a lot of patience, and different analysts come up with different results. Machine learning algorithms can be trained to recognize and distinguish seals in satellite imagery and count them automatically. Researchers can then use this accurate data to monitor seal populations over time and study their behavior and habitat more effectively.
Hear that? Pretty annoying, isn't it? It's the sound at a frequency of 50 Hz. It's quiet but permeates everything around. What if this hum followed you wherever you go throughout the day, week, month, around the clock? You can't sleep, you can't focus or study or work. You want to scream in frustration, but the sound continues to torment you. That would be awful. Unfortunately, this nightmare is a reality for the residents of the Scottish Isle of Lewis. Day and night, about 200 people go crazy over a strange low-frequency sound. They say it seems to be pulsating, causing headaches, dizziness, and the feeling of an existential crisis. And no one can find its source. The islanders decided to create a special Facebook group to discuss the causes of the sound, share their experiences, and support one another. One woman says the hum is impossible to ignore. It sounds like it's shouting in your face, demanding your attention. For this reason, she hasn't been sleeping well for several weeks. I understand. The island administration, as well as the residents, are powerless to solve this problem. Now, the locals used a spectrograph to study the hum. The device showed that the sound had a constant frequency of 50 Hz. It spreads all over the island, but it doesn't originate from within it. This means the source may be far away from the shore. An underwater laboratory? Testing some kind of a secret invention? A harsh experiment on people? An unknown sea creature? Ooh. People develop a lot of theories, but nothing helps. The country's top leadership may be aware of the nature of this sound, but they probably don't want to talk about it. It sounds like nonsense, but let's visit the small northern Irish town of Omagh. Its residents reported a constant buzzing that prevented them from sleeping. They just woke up in the middle of the night and heard this hum. The sound spread in different parts of the city, and no one knew its nature. People heard the sound every night. But fortunately, the city council coped with the problem. They found the source of the hum, but for some reason, they refused to tell the residents about their investigation. Moreover, they said the sound could return in the fall. The locals demand the truth. There's a big doubt that they will get it. Another case of a strange sound happened in Windsor, Canada. It's an industrial town located across the river from Detroit, Michigan. Its residents have been hearing the hum for many years. It sounds at such low frequencies and is so quiet that some residents often cannot understand, is the sound real or is it a hallucination? Other locals say the hum is so strong that it makes glassware rattle in the cupboards. Some people believe that some secret invention used to control the weather produces this sound. But the reality may be simpler. The most plausible theory claims that the source of the noise is on Zug Island. Blast furnaces located on the island release pressure and produce a strong rumbling sound. This is necessary to keep the equipment from exploding. Well, yeah. According to this theory, the sound gets reflected from metal drums and machines and then goes beyond the island and crosses the Detroit River directly into Windsor. It sounds realistic, but no one has confirmed this theory. Yeah, there have been investigations. The Canadian authorities compiled a report, but it was kept secret. The only thing the locals received was an official comment on the city's website. Quote, "While it is not possible to extract the exact source of the hum, possible sources may include quarry activity or industrial ventilation systems." End quote. But where did the version about the blast furnaces come from? They were mentioned in an abridged version of this report without any details getting disclosed. Another problem with the hum research is that Zug Island is located on private American territory. Scientists from Canada were banned from conducting investigations there. Canada, Ireland, Scotland. Anywhere else? Oh, yeah. The residents of Bristol, England have been hearing a mysterious hum since the 70s. And not only them, maybe you, the one who is watching this video right now, hear it too. If that's the case, then you're one of about 4% of the world's population affected by this problem. No, seriously, what's happening? Let's figure it out. The first mention of the hum appeared in the mid-70s in England. A small digression. The Industrial Revolution also began in England. Keep this fact in mind and we'll come back to it later. So, people perceived the hum of Bristol like a quiet, annoying sound. But over time, it began to drive the locals mad, and of course, they demanded a solution to the problem. There were investigations that led to nothing. One theory said that it was the noise of industrial fans working in a warehouse in a neighboring city. But the warehouse has been closed for a long time, and the hum is still there. In 2015, scientists suggested that ocean waves could cause the annoying sound. When they collide with ridges and continental plumes, they release a sound wave, blah blah blah. It's too far-fetched. Other scientists have suggested that vibrations caused by volcanic eruptions and earthquakes are the reason for everything. It also doesn't sound plausible. About 8 million lightning bolts strike the planet every day. These impacts create an electromagnetic charge. This energy causes the air between the surface and the ionosphere to resonate, and nope, that's all wrong. Sea waves, earthquakes, lightning? Seriously? Then why do so few people hear the hum? No, there must be something else here. There are many theories, but look at the whole picture. What do you see? In Ireland and Canada, the information about the hum is classified. It appeared in England in the 70s, and there are no earlier records of it. What does this tell us? The nature of the sound is not related to nature. It's about people and technology. England became the first industrial country. In England, the sound appeared for the first time. If this phenomenon had bothered people before, we would have found some records. It means it may have an artificial nature. Why would they hide any natural phenomena from us? What if the annoying hum is the consequence of our technological advances? Factories, cars, power lines, cell towers, airplanes, microwaves, power plants, all of these clog the air with sound waves. It's possible that all these things cause the hum, but only some of you can hear it. Listen carefully. Perhaps there's a buzzing hum in your ears too. Ooh. But let's not panic and end our video on a more positive note. While in some places the mysterious hum drives people crazy, in others it becomes the cause of a real celebration. Welcome to the bayside town of Sausalito in sunny, sometimes foggy, Northern California. In the 80s, a loud hum appeared here, which prevented people from sleeping. The investigation revealed that the cause of the hum was marine creatures. Thousands of toadfish swam to this place every year. These are fish that can emit unique sound waves. The human ear can't hear this sound from a single fish, but if there are thousands of them and they scream at the same time, then a whole town can hear their party. Sound waves come out of the water and reflect off the houses located next to the shore. From there, the waves spread further and can cover a huge territory. And that's what happened to Sausalito. Now, once people figured out the nature of the sound, they didn't look for solutions to get rid of it. They just decided to celebrate. The locals created the annual Humming Toadfish Festival, where they had fun and imitated the sounds of the fish. They dressed up as toadfish, toads, and other creatures. Unfortunately, the festival ceased to exist in 1990 because toadfish stopped coming to the city. They went to another place and only occasionally appeared on the coast. So there.
It's September 1977. You're playing one of the first video game consoles released in North America. You step outside and see the whole neighborhood waiting for Voyager 1 to launch. It's a super sunny day, so you squint a little, trying to see what's happening. You live in the neighborhood right outside the launching station. You get yourself some food and watch the Voyager take off into space. You're so impressed, you decide to dedicate your career to working with NASA. 35 years later, you're now a senior official in NASA, specializing in Voyager 1. It's 2012, and you're sitting in the control room with your colleagues. Everyone is staring at their computer screens as they work on the Voyager. You're sitting on the top, overlooking everything and making sure all systems are in check. This day is special, as Voyager 1 is about to exit the heliosphere, which is a science word for the outer shell of our solar system. It's a bubble of space affected by the solar wind, which comes from the sun. By 2021, it got 14 billion miles away from Earth, which is equivalent to 153 astronomical units from the sun. 1 astronomical unit is the distance between the sun and the Earth. The craft was originally meant to fly by Uranus, Saturn, and Jupiter, and toss itself from one planet to another with the use of their gravitational pull. Everyone is impatiently waiting for it to exit the heliosphere. 3, 2, 1, and it's officially out. All systems are normal and functioning. You praise your team for doing an excellent job. With Voyager 1 reaching this far, there's still tons to explore in outer space. You were once a young adult watching the craft launch outside your neighborhood, and now you're the main person in charge of the operation. 9 years later. Since Voyager 1 left the heliosphere, you've been checking up on it every now and then, making sure all systems and functions are in order. It's been sending back measurements of the interstellar medium. It's the area between the stars of our galaxy, consisting of ionized materials. Ionized is basically a simple version of a molecule or substance. The interstellar medium is an electrically charged state of plasma, or ionized plasma, and is very unstable. It's like going from lightning in a thunderstorm back to calm rain in a matter of seconds. The plasma up there is different than the plasma on Earth, in that it's difficult to filter out. There are around 0.06 atoms for every cubic inch in the interstellar medium. The air we breathe on Earth has billions of atoms. By measuring the plasma in the interstellar medium, we can further understand the behavior and structure of chemicals and gases. It's possible that the oxygen we know and love on Earth is different than the ones out there. One of your main tasks is to learn more about how the solar wind from the sun and interstellar medium interact with each other to create the heliosphere. So, after doing some routine checkups and other maintenance work on Voyager 1 from the control room, you notice something strange coming from the screen. You sit in front of the computer, crunching the numbers of the plasma vibrations and convert them into an audio file of about 3 kilohertz. You click on it and listen to an eerie, subtle hum. You and your team are surprised that these vibrations occurred in such a small frequency. Given that space is massive, something like this might mean life on other planets. Everyone else at the station rushes to the control room to listen to that sound from outer space. It's monotonous and faint, but it's definitely coming from outside the heliosphere. You run the numbers over and over to make sure it's not a fluke, but it's on point. You make sure your team doesn't spill the beans to anyone outside until everything is known and clear. You get into beast mode with work and try to catch the sound again, and it remains. You can't sleep trying to think of something that could be producing this hum. A few days pass by, and the sound is pretty consistent. If there was some life out there trying to communicate with you, then surely it would have said something that can be deciphered. You analyze the audio files once again, trying to see if it's some phonetic language you don't know. You call in a linguist to see if she can make something out of it. You and the squad gather around, waiting impatiently for some answers. After a while, she believes that it might be someone out there communicating with us, but the only way to find out is by sending something back to them. You arrange a meeting with your team and try to figure out what message you can send. After much thinking and lots of coffee, you decide to send them one phrase in English. Who are you? You send out the signal through Voyager 1 and wait for any changes in the hum, but you don't get anything straight away. It may take some time for a response. You wait all night and still, there's nothing. It's starting to look like there isn't anything out there. For the next couple of days, you keep sending out phrases for anything to pick up. Since space is a vacuum, sound waves can't travel, so sending out voice messages on a large speaker won't work. You locate the source of the humming and aim for it when sending the audio file. Every day, you send something different, but still, you don't hear anything from them for a week. It seems that intelligent life in the distant world isn't real. The areas between the star systems in a galaxy aren't necessarily a complete vacuum. That's where the interstellar medium is. It contains gases, dust, and cosmic rays, which are energy particles. After many months of this constant humming being produced, you still try to figure out what's going on. You sit there, remembering the time when the Voyager was first launched. You remember running outside after playing some video games. You couldn't see properly because of the sun, and you freeze in your spot and have a eureka moment. You go through some notes taken in the past. The answer was in front of you all this time. Every now and then, the sun sends a burst of energy that causes the plasma of interstellar space to vibrate. Scientists can measure the frequency of waves when the plasma vibrates to show how close they are to each other. And on the day when the hum was delivered, there were some irregular frequencies coming from the sun. So that hum might have been the plasma vibrating in a weird way because of the sun flares. But these low-level vibrations last longer than quick jumps and spikes. They're fainter. You run the tests again and find out that it's not some intelligent life forms out there trying to talk to you. It's the little vibrations caused by sun flares. You notify your team about this breakthrough, and everyone's celebrating. But after all these tests and research, you still don't know why plasma in the interstellar medium vibrates in such a way. Those answers will have to wait. 2027. It's been 50 years since the launch of Voyager 1. You're way into your senior years and just retired from NASA. You have many scholarships in your name and programs for young people who want to learn about space and science. You go back to the control room once more, where you thought you had discovered intelligent life on a distant world. Then you remember all the good times you had. You say goodbye to everything, knowing that this is Voyager's final moments. It was built to last up to 50 years. After that, it'll just be a floating object in the vastness of space. It's already surprising to know that this is Earth's most distant object from us, but it's time to let others take your place. You shut off the lights and close the door. The Voyager makes one last beep before eternal silence.
Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did the zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bode's void in the constellation of Bodes. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars, stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be slingshooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space. Thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow. NASA is on the hunt for Dyson spheres. Turns out there are 60 stars that give off weird light patterns. This means there might be some extraterrestrial technology nearby. A team of scientists has developed a new way to search for advanced civilizations by looking for Dyson spheres. All forms of life, from microbes to us, need energy in order to survive. As living creatures keep evolving, their energy needs grow. We started with small fires, then moved on to coal, oil, and eventually solar panels. Now imagine a super advanced civilization that has used up all the energy sources on its planet. What's next? Their host star, an almost limitless power source. This is where the idea of Dyson spheres comes in. It was made up by the physicist Freeman Dyson in the 1960s. This idea says that, hypothetically, we could build an incredibly big structure around a star to capture its energy, like some sort of gigantic solar panel. Advanced civilizations could use it to power their planet and even interstellar travel. Right now, something like this would be impossible for us to build, but maybe someone else in the universe has managed to pull that off. Scientists gathered lots of data from surveys of stars. They analyzed over 5 million objects and found some candidates. Of course, extraterrestrial civilizations might have completely different technology, so astronomers aren't looking for actual giant shells around stars. Instead, they're looking for technosignatures. These are weird things that might indicate the presence of something technological and can't be explained by known natural sources like galaxies or nebula. For example, a structure like a Dyson sphere could give off unusual infrared radiation. This is because, while absorbing a star's energy, this structure would give off crazy amounts of heat. Out of millions, they identified 368 potential candidates. Further filtering left them with only 7 objects that could be Dyson spheres. Now, usually, weird infrared flickering happens from giant crashes in space, like planetary collisions. Warmed-up dust and rocks get scattered around and give off strange lighting patterns. These are called extreme debris disks. The researchers think these 7 objects could be M-type stars, also called red dwarfs. These are stars that are very small on the space scale and a bit fainter than our Sun, a yellow dwarf. Stars like that don't usually have warm dust and rocks around them, but scientists need to do more tests, like looking at the light in detail, to be sure about their discovery. There was another study that found 53 star candidates with similar excess infrared radiation. But these also need to be checked. Scientists plan to use advanced tools like the James Webb Space Telescope to take a closer look at all these candidates. One famous candidate is Tabby's star. Scientists even made a joking name for it because the paper about this star had the subtitle, "Where's the Flux?" Think of an acronym yourself. Now, it's a bit hotter and more massive than our Sun. It's caught NASA's attention because of its unusual, irregular light dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turns on and off a flashlight. At first, you might think this is just because some big planet is passing in front of it, or a comet, but we're talking up to a 22% drop in light. No planet could manage to eclipse a quarter of a star, and that's where the name comes in. So, another explanation is a Dyson sphere or some similar megastructure. Someone also suggested that the dips might be caused by fragments from a broken exomoon orbiting the star. There are other stars that show similar traits, but there's no solid evidence to support this. So for now, scientists just don't know. So astronomers are on the hunt for any giant structures. There are many variations of what a Dyson sphere could look like: rings, bubbles, a swarm of satellites, a giant shell, and so on. A Dyson shell would be a solid, rigid shell completely enclosing the star. This is the most extreme option, the hardest one to build. Also, if other civilizations built that thing, it would fully cover the star's light, and we simply wouldn't see it. The inner surface of this shell could be lined with habitats, and we could simulate gravity by rotating the structure around the Sun. A Dyson swarm is the simplest option, a bunch of solar-collecting satellites and habitats orbiting the star. It would be a lovely place, with people living in many space stations or mini space houses within the swarm. Each little habitat would have its own air, life support systems, and artificial gravity. We could also grow our little farms there. And imagine the view. We would see a constant bright sky with other habitats visible across the expanse. A near unlimited energy of a star would mean we could advance our technology very fast, manufacture tons of materials, and terraform planets within the star system. But building and maintaining a Dyson sphere would require advanced robotics, AI, and tons of money. It would take us centuries or millennia to get there. Now, giant megastructures aren't the only things that scientists are looking for in order to find extraterrestrial life. They also look at the planets. Now, planets must have certain characteristics to be potential homes. There should be liquid water and an energy source, something to drive these reactions, creating the building blocks of life. Turns out such conditions aren't rare at all. Our search showed that there might be more than 60 billion potential habitable planets in the Milky Way alone. Unfortunately, we can't look at them directly or land there. So we have to use tricks, like detecting water and good gases in their atmosphere. Recently, the James Webb Space Telescope found possible signs of life on a planet called K218b, which is pretty close, about 120 light-years from Earth. This planet is 9 times the size of Earth. It has clouds of liquid water but a different atmosphere, full of gases like methane, carbon dioxide, and dimethyl sulfide. Regular oxygen-breathing life wouldn't do well at all there, but on Earth, dimethyl sulfide is produced by life forms like phytoplankton. They also discovered that weird wiggly planets could be signs of advanced extraterrestrial civilizations. In our solar system, each planet has its own orbit. But the universe likes to surprise us. Surprise! Models show that there might be planets that share the same orbit. For example, it's possible if the planets are evenly spaced around the star, minimizing their gravitational impact on each other. Or the so-called horseshoe configuration, when planets speed up and slow down in relation to each other, moving in funny wiggly ways. These horseshoe systems can hold up to 24 planets. This is one of those things that are possible but very unlikely without some help. Normally, gravity would immediately destabilize such systems. This means that if we ever find a star system with 24 planets sharing orbits, it might indicate that some advanced civilization decided to lend a hand. They also might contact us themselves. The search for extraterrestrial intelligence began in the 1960s when astronomer Frank Drake started listening for radio signals from space. Today, they persist. Astronomers listen for leakage radiation from other civilizations, which are radio waves unintentionally sent into space from everyday activities. Recently, they detected radio waves from YZ Ceti b, a planet super close to us, just 12 light-years away. This means it might have a magnetic field, invisible shields that are very important for protecting life from the solar radiation. But YZ Ceti b is probably too close to its star to be habitable. But there are a lot of places for such a signal to come from. It turns out there are 1,000 star systems in our galaxy where they can see us in the sky. All these stars have a perfect view of Earth passing in front of the Sun, making it easy for potential extraterrestrial astronomers to spot us. So, there are over 1,000 star systems that could be watching us right now. And if we study them, we might one day find evidence of intelligent life looking back at us. Hello!